I have cut so much out of this, I kid you not, I've spent well over a month on this. And I'm talking about like whole days. I mean many whole days. Yeah, last bit of solder mask been applied to various points here. So it does look like an absolute battleground, but you know what? It's not come out too bad actually, and it's rock solid stable just now. The scope was very helpful on this. There were 3 or 4 different issues I had where, you know, it's not doing anything, suddenly it stopped booting again, or you're getting a green screen again, and just start scoping everything. Scope every single pin. Oh, hang on a minute, what's that? That's like 0.8 of a volt. That's not TTL level or CMOS level. So yeah, let's have a look at that pin. Oh, lo and behold, there's some resistance instead of a short to wherever it needs to go. So that's the sort of thing you need to do, and you need to compare to the schematics. And because there's no PCB Explorer layout for this, this is what makes the 3000 really hard. I wish Chucky would just allow a higher resolution of his images, but it's very good that Chucky shared that. I couldn't have done this repair without that information really, so thanks, massive thanks to Chucky, John Hurtle. Right, so a cold start this morning and it worked fine. Booted straight up. So besides a bit more solder mask paint and cleaning up, I've ordered some brand new Panasonics for this. I was looking at the DRAM here, came back to something I picked up on when I was trying to diagnose the fault of the RAM actually, and that is like logic level mismatch, and I was like, is there some contention? Well, the problem is still there, but I don't think it is. It's just like little peaks that are in a frequency, so it's like, it's noise, it's something that needs decoupling. And I asked Steve Leary about it, and he said that exact sort of thing really. He said that maybe they've under decoupled on the RAM side for some reason, and I think that's what it is, and I'll put the screenshot up here. So it'd be interesting to see if that tidies up anymore. I don't think it would do, but yeah, nevertheless I think Stephen's theory is right. Look at those little peaks, they're in a set frequency. Yeah, they're in a set frequency. You know, that stuff's appearing in between where you've got a low signal, you've just got a little bit of stuff leaking through there. You know, it's like, I think that's what's going on. It could be one of these transceivers or something that's allowing something through, but it's on both halves of the data bus and it's on all data bits, so it's a bit strange, isn't it? I think what I'm going to do though is obviously I'm going to recap it, put some Panasonic capacitors on it, and see if that makes any difference. It probably won't, to be honest, but it might make a little bit of difference. I'm going to fit the 040 card on here. So this is the one, there'll be a link top right to this, we built in a previous video. My understanding is you just literally just plug this in, it should disable the, is this going to fit here? Yeah, it's pretty tight. It should disable the onboard CPU. So let's hang on, let's just check the jumpers first. So we've got 2516. These are for the yeah, you can't see these because of the thing there. There's a couple of jumpers here for internal, external. We need to set those to external. Let me just do that. Hang on. Yeah, so the ones there that you can't see, I need to swap it over. I don't see any others, so I think this should do the job. I hope this works. Yeah, we've got a difficult screen there, so that's not good, is it? Yeah, so I'm not sure why that card doesn't work with this. That is a concern. I will clean the slot up a bit further here just to make sure that is super clean and give it another try perhaps. Right, so a little bit of research and everything's starting to make sense now. It's working at the moment, but obviously it's not working with a CPU card. I got it working with an A30 card from a 4000, but it's the same speed. It's 25 megahertz, isn't it? The same as the ones on there, this one. And some of these shipped with 16 megahertz chips. Why there are jumpers for 16 or 25. So yeah, and it's Rev 9 this, which is weird, isn't it? Because it's a later board, but it's got an early kickstart. And then I was thinking, is it the kickstart? Well, as I say, I've done some research. Yeah, it's the kickstart. This old 1.4 Proto kickstart is not compatible with 040s. The 040 card came out, I think, around the 4000 time, and then people started to backfit them into the 3000, I think, but Commodore didn't recommend sticking them in the 3000 because of heat issues and clearance, because it'd be pretty tight, I think, with the heat sink and everything, and there's something goes over here in the case. Obviously we don't have the case. So yeah, a number of twists and turns there. The reality is we need a later version of Kickstart before that slot will work with an 040 or an 060, which kind of makes sense, doesn't it? It is an old Proto. And if you think about the way this boots, it doesn't boot straight to Kickstart, does it? The Kickstart we know and love, it boots very quickly into that menu. Yeah, so no way around that. And I don't have any EEPROMs to stick Kickstart on. But we do know the slot works because the 030 works in there. So yeah, I'm assuming that when it was in there, it was actually disabling the onboard one, but I did have the jumpers all set accordingly. So I think there's no issue there. So something else I've been told here, without the daughter board here, apparently these, you know, you can't boot them. Well, that's not true. It does boot up normally here. There is a delay there. Well, it looks for the floppy drive and stuff, but yeah. So how reliable it would be without that, I don't know, but anyway, it does work without it. Yeah, so I finally got Kickstart 2 working, Super Kickstart from floppy. Yeah, what was happening is I tried a 204, that didn't work, and then I tried 2, and that didn't work, and then I just went back and thought, well, let's just check that version 2 disk again, I'll verify it. I put it in the 1200, and it straight away said, you know, question mark next to the disk, as if the disk wasn't written properly. So I thought, oh, maybe it's corrupted. So I've wrote it again. This time I put the write protects on, and it just works. It's booted straight up. So, can we boot from SCSI that way? I don't know. Maybe, because if I did a keyboard reset now and SCSI was connected, it may then boot from SCSI. So let's try that. Yeah, so the problem is here, it boots from the SCSI right at the start, so I'll hold both mouse buttons down. Yeah, so we should see one flash there. Alright, we got the menu. So now we can choose boot from floppy. It's booting from floppy again. That's good news. Yeah, well, my recommendation to Cathers is to get 3.1 or 3.2 straight away for this. Now, I'm not sure if I'm going to be able to do a keyboard reset on this actually, because this keyboard's not been modified. No, it's not been modified. What I could do though is bring my 2000 keyboard over, because that's got the reset mod. Yeah, Control Amiga does nothing on this. This is the blooming problem, so now I can't boot from hard disk that way either. And what I mean here is I'm using the adapter I made in one of the 2000 repairs. I think it was part 2, wasn't it? The first 2000 I looked at. So we're using a 500 keyboard here, so let's just disconnect that. My other keyboard is a 500 keyboard, but I did the mod to it to get the reset working properly. And when I say reset, I mean the keyboard reset. So that's this keyboard. Yeah, you may have seen this in a previous video. There'll be a link top right to that. So let's now get this keyboard up. Right, so let's kickstart. We'll do Control Amiga. Ooh, we've got a reset. And it's looked at SCSI. And it's booted from floppy. Let's just take the disk out the drive. It's like, how did you get it from boot from hard disk? Because that's the thing, it's like this version of Kickstart doesn't seem to support boot from hard disk. It looks at the drive, yeah, it's not doing it. Yeah, it's not booting. Watch here, you can see it flash. Watch, it looks at it and then just comes straight up with the screen here. We could try holding both mouse buttons down again. Of course now I don't have enough arms again, so Control Amiga, hang on, I can't reach the control. I'm gonna have to try and press control with my nose. Seriously. Oh, hang on, let's try and, I can reach both Amigas. Why did they put the keys so far away from each other? And we're doing Amiga, and I can't reach control, but I can if I hold both mouse buttons down and hit control of my nose. There we go, it's booted. Someone's bound to pipe up and point out an easier way I could have done that. So we've got DF0, let's do, this is the thing, I don't know how you can't do anything here. Startup sequence, enabled, DH0, it's like, why is that yellow? Use? Ugh, I don't know. Yeah, so I'd have to faff around now and install like a bootable Kickstart ROM onto the hard disk in order to get the hard disk to boot. I honestly can't be bothered doing that. What I do know is every single diagnostic I run on this and every game I test from floppy and stuff works fine. We can boot from SCSI. I just can't boot from the SCSI hard drive with the right version of Kickstart, which means I can't test any games and things off it. So yeah, you're just going to have to, like me, have some confidence that everything we've done is good here. Right, the Panasonic capacitors have arrived, so I've just got this out of the ESD bag. It's not been used for approximately 6 days. Now we fixed this earlier, but Cathers has said I can keep this, which is amazing. It means if I ever am unlucky enough to get another Amiga 3000 board, I say unlucky. You know what, I would do it again, as painful as this has been if I got one of my own. Incidentally, there's a sell in China selling these at the moment, RAMs for these, so I'm going to point Cathers in that direction. I did consider ordering, I think it needs 8, doesn't it? 1, 2, 3, 4. Yeah, it needs 8 to take that to 16 meg, so I'll let him make that decision. I think it worked out about 20 quid for 8 meg. So, you know, or something like that, 15 quid I think, because I was looking, it was like 30 or 40 quid to get 16 of those. I almost did it, but yeah, anyway, I've spent far too much time and money on this as things stand. Yeah, with Patreon funding, you know, it provides a lot of the consumables and things, but I was able to buy another video cable. This is my old one, so I'll leave this one here now on this bench, and then the 4000 over there has got its own video cable. At some point I'd like to perhaps get one more so that I can connect the 2000 up and just leave it connected. Maybe get a switch box or something like the one here. You know, I've got a SCART switcher there, but well, it's not a switcher, it's just one of those ones where you can have multiple things plugged in, but I could just plug in and unplug as I need things, and it's dead convenient. You know, the other thing with this is I've got composite at the back here as well, so when the C64 comes to the bench I could just plug it there instead of messing around with the back of the TV. Yeah, so I'm just going to proceed with the recap. I cleaned everything out. I got a new nozzle for this. It needed a new piece of silicone. Cleaned it out totally thoroughly. Cleaned the desolder station. I'll stick a picture up here. Yeah, you can see all the decrepit solder that came off 3000 when it suffered Varta damage. It took me ages to clean the desolder station out. Yeah, so and then, yeah, and of course then we did this, and then I did the main solder and iron stuff. And I'd service this stuff, you know, so cut any pieces out that got solder on, and you know, you wouldn't believe how many bits of solder. It wasn't just that one, it's the one that goes with the Heiko as well. This thing here, it was absolutely unbelievable state. So those will probably need replacing at some point. I mean, it's just a consumable, but point is, you know, all these things take time and they all add up and stuff as well. So yeah, I must have spent an hour and a half cleaning all my tools just before we got to this point. Right, let's now look it over. And incidentally, all those things were clean and tidy, so you can see there's still cleaning needed here, some more solder mask, more bits of glue and stuff, but yeah, it's alright. We need some solder mask down here as well, solder mask paint. So yeah, we've not finished cleaning up the underside yet. And look on the top side, yeah, there's lots of bits of solder mask here protecting things, and it is a little bit coppery up this side, but everything's clean, connectivity's all good, and everything so far is still working. Yeah, that looks a bit battered, doesn't it? So yeah, one or two of these need replaced anyway, just because they've got a little bit battered. There's a big dint there, look at that. Never even spotted that until now. Yeah, so physically these are a bit smaller. They're 16 volt, 470 microfarad. They're the ones with the legs already cut down, which is, yeah, annoys me when they're like that, but nevertheless. And then we've got 47s here, so those are the majority caps that are on here. There are some bipolars for the audio, which I think about here, but most of them are the 47s and 470s. The big ones are the 470s. So yeah, I'm just going to sort of start up here and just work my way across, I think. And I'm just going to use the solder pump. And I think we need to add a bit of solder. It contains flux, so this is the thing, a bit of solder containing flux. It kind of wets up the point, and then the heat transfers a lot better. Yeah, that's not desoldering very well. And this is the problem, is that the rails these power caps are on, because that's what they are, they're all on power rails, they absorb so much blooming heat on the VCC and ground sides that you can spend a lot of time faffing around trying to get these darn things off. You could argue a bigger tip would be a good idea right now, but I like to try and keep a small tip, otherwise you kind of start to mangle the edges of the pads if you use, you know, a larger tip. But then again, it probably comes off a lot easier when you've got a larger tip. So I'm just going to pull from the underside here, wobble a bit, so I like that side. Yeah, it's kind of rejoining back up when it cools. This is the problem here. So we'll just try and pull through, I think, and then I'll try and unblock the holes. Oop. Yeah, this is the thing, you don't want to slip and scratch a trace there. I didn't, I just slipped there. It's one side out, two sides out. So yeah, ground towards the edge facing me here. Obviously cleaning around and under these while I'm here as well, and around the area. You can see that browny horrible black mark? Yeah, there was like a weird black discoloration to the surface there. It wasn't corrosion, so I thought maybe that one's leaked. Anyway, positives up this side, ground towards the right. So just testing part way here, I do need a break. So yeah, we've replaced all of the caps on this side of the board here, and free are the ones up here. I was very careful to make sure polarity was right way around, as well as you know, sort of checking to ground and against the schematics. Like I think one of these is +12, one of them is -12. I think the -12 might be the one I've not done over here. So there's a few more. I think there's a 100 there, so I'll need to go and raid my spares for one of those. And there might be a 4.7, but most of these are 47s, and most of the other ones, the big ones, are 470s. So switch it on. And the good news is it is, I think, still working. Yep. So testing the caps we've done so far, I would report if there's any anomalies here, but yeah, ding ding, good ESR, good capacitance actually. But these Shui caps, yeah, I'm not that keen on them. Often the 3300s and A500s do need swapping out in many cases. So let's test another one. Yeah, not too bad. You can argue the capacitance is a bit low there at 460. But, you know, these are like, I don't know, they're like ±20% or something. This is what they were like back in the day. I had another ESR meter that I used to use, and yeah, 456. This is what they would show, like 30 years ago or more. Did they need doing? Probably not. But I just thought it would be a bit of a bad thing, really, to not do them while we're here. And maybe there's the odd one. Is this one balked? Hey, this one's balked, look. Let's just try it again. Maybe it's not hooked on properly there. Right, try it again. Yeah, that one's bad. So yeah, there we go. I stand corrected. Oh, and this is the one with that dint on the top, look, it's no wonder. So yeah, that capacitor was a problem. Another 470 that's okay. Another 470 that's okay. So yeah, there was just that dinted one so far, which you can kind of understand and explain. And in fact, look at it here. It's been really squashed. It's not just the bit on the top, it's this bit here. That's had a massive impact, that. So another 470. Again, it's alright. So just testing some of the 47s. Yeah, a bit low on capacitance and 1 ohm there, and it just dinged once. Another 47, that one's good, that dinged twice. So yeah, even one or two of the 47s seem to be not great. Yeah, I won't show you them all, but that only dinged once, look, and it's 1 ohm, so yeah. Right, I am relieved to say we are getting very, very, very near the end. I need to test the serial and parallel ports. I'll do that next, I think. But yeah, a full recap. The only thing I haven't recapped is the daughter board there, but yeah, there's like 6 caps on there. If Catherine wants to do that, it's easy to just unplug it and recap it. It's because the axial ones, you know, I've not got any of those. I don't want to wait for any more parts. I think it's been on the bench for like over a month, this. So yeah, the longest repair on my channel. This is actually, in some ways, as I say, harder than the Archimedes was. And that's because it had an existing fault. You know, we had the issue with the 244, and it could be that the 245. It could be that the 245 was killed by the corrosion, but I think that was a pre-existing fault actually. So anyway, we'll just test the serial parallel ports, and then I'll bench test this for a day or two, and then I'll just have a final clean up on the top and bottom side. But yeah, it's pretty darn clean now, but I'll be hoovering it and defluffifying it. You know, any sticky cotton fibres that are stuck onto anything, I'll get them off. There's hardly anything on it though. It's pretty pristine really. Aside from the horror story here, you know, it's actually pretty darn good. I'd be really happy if this was my board. Right, so the dongles are in the back. I'll show you those in a minute. But I'm sure you've seen it all before anyway. Let's boot test kit. And if we're going to serial parallel, serial. Come on, please don't be bad. Serial looks good. Let's do parallel. Woohoo! Everything works. Yeah, so the only other thing to test is the external floppy interface. I'll test that off camera. I honestly can't be bothered filming every single thing I'm doing on this, hence why we've skipped over 90% of it actually. And I've still got an insane amount of footage to edit. But if I just switch that off, yeah, and well, I'll sort of move the drive out of the way, you can see we've got one of the things in there. And there's 2 parallel ports, and I think maybe this is if you've got a bridge card. I honestly don't know why they have 2 parallel ports on these. I think it's the same with the 4000, doesn't that have an extra parallel port? So yeah, it's just a you know, a DB25 with a couple of wires looped back in the inside, so you can build one of those yourself really easily. Just buy the connector, and in there, when we were testing that a minute ago on the screen there, it actually shows you which pins need joining to which pins, so it's really easy. Just have a wire You know, this is like 4 or 5 wires in one and 2 or 3 wires in the other. I think the sealer one's dead easy, it's only got a couple. Behold, a pile of jumpers. Yeah, I finally got around to sorting out this tray full of all the screws for PC mounts and stuff. So they're all the ones you would have got back in the day for building PC compatible machines. And I got a giant pile of washers here as well, so I'll stick those with my washers. Anyway, the reason I started separating those things, I swapped a few jumpers on this board, but they're not the kind of period correct ones, in the sense that they don't have a gap on the end. Right, so I'll show you those jumpers in a second. The other thing we need to do here, because it just won't be period correct without a proper Varta battery. So yeah, I'm going to install this. I need to unblock the holes here first. I'm kidding, of course. I'm going to stick a CR2032, hold on. No, don't stick a battery back on a board. Well, yeah, stick a CR2032 back on a board. You will have to change it every 18 months to 2 years, probably. The charge circuits are different between nickel metal hydride and NiCad, by the way. It was something that just reminded me from watching one of my mate Vince's videos. But yeah, nevertheless, yeah, don't stick one of those types of batteries back on there. Yeah, I need to unblock the holes, and then it's hopefully going to fit diagonal there, maybe, like that. So we're going to need to do a mod here and fit a low forward switching diode somewhere, just so that this can get power to the real-time clock chip, but the charge circuit can't charge this. So yeah, it should be straightforward to do. I'll report back on that in a sec. Now the two that I've replaced on this, because they were super corroded, the tops are like that, solid. The ones that were already on this board have got like a hole in the top. Yeah, that's a good example of one. So yeah, it's not going to focus very well, but you can see a bit of copper there, you know, the goldish looking surface. Yeah, so those are more in line with the ones that were already on there. So I'll fit 2 of those. Yeah, and if that's going to focus properly, you can see what I mean. So the tops are able to poke out the thing there, you know, the surface of it. The other one's solid. And you can see the other one here. We swapped that tantalum earlier, by the way. Yeah, so again, it must be in the top position, but I'm going to replace that because it's got a solid top and it kind of sits a bit proud, you know, it sits a bit high up. It just doesn't look right. And again, one of the ones that should go all the way down like that. So you can see the pins sticking out the top. It just looks better, it looks correct, so they're the same as the other ones. Right, I measured on continuity. This is the ground side here, and it kind of makes sense because it's connected to all of this. Yeah, these 2 here are the positive side. This one up here doesn't go anywhere. This is the one that's going to be best aligned with this, because if we try and fit it that way, this socket gets in the way, whereas if we fit it that way, it's going to go in okay. This is the ground side here, you know, that captures the underneath of the button cell, so it is going to go that way there. In terms of trying to desolder, don't stress yourself out trying to desolder certain points like that. Just use a drill bit, as I showed earlier. I had to use a drill bit like this on 2 or 3 of the cap positions on here, just on a ground or a VCC, where even with the larger tip set to 450 degrees, impossible to desolder. Absolutely impossible with the Heiko. The desolder station was even worse. So this is the thing, you need like a really power hungry iron, you know, something that can dump a lot of number of watts into the board, and then you start to lose pads and things. So yeah, I would always just turn to the drill bit. I really would. You know, let's say test it out on one of the holes first. You know, I'll show you if we can find the thing. Where's the hole there? Yeah, I just drilled this one out a minute ago. Yeah, perfect. There's no damage on either side as a result of doing that, because the lead that blocks the hole is really soft, it's malleable, you know, so with a drill it just comes straight out. Of course, the key is making sure that you have got a divot, if you like, a point on the centre, so that when you start to drill you're not misaligned and start to tear the pads and things up. So yeah, some work with desolder braid and flux and the desolder pump to start with, to get, you know, a little indent in the surface so that the drill bit is definitely in the centre. That is what you need to do. And the trace that goes from the positive side here on the top side is broken. It was one of the ones I didn't fix deliberately here, because now we can have a diode from the underside of the positive straight to the real-time clock point over here. Yeah, there we are. So I'll just go solder that on. Yeah, so it does look super messy under here, if I'm honest, but you know what, I'd be happy if this was mine. The worst part is here, because there's just so many connections around there. If I spent more time trying to fix the traces on the top side with coil wire, then obviously it would be a tidier repair. Anyway, all I'm going to do though, like I say, is after we've done the battery is tidy some of the stuff up. I need to check with him if he's going to have this in a case. If it's in a case, it's all right, because all of this stuff here is going to be stud off, because you've got, you know, like a lump that comes up there, and there won't be any issues. But if you were to, you know, have this on a bench now and press the chips really hard, you start to pierce. So this is where you've got to be careful where these wires are. The pins that are sticking out start to pierce the wires, and I had that on a few wires, and I had to replace the wires, and then this is when we used the hot melt glue. Anyway, that's one side done. So the other side is here, and I think there's a fixed wire there, isn't there? No, there isn't. Yeah, you've got to be careful not to melt your blooming fixed wires whenever you come in to try and solder anything. You know, this is the added complication with having so many fixed wires on. You can test connectivity. I'll just show you the basic steps I'll do with any battery model like this. So that's the ground. And I'll meter 0.00. Yeah, just test to the positive side, make sure there's nothing there. No. And the VCC on this, or VDD actually, I think these are rated between 3 and 19 volts or something like that. It's a CMOS device. In fact, it's not even 3, it's 1 to 19 volts, and this is why when your battery goes down to about 1 volt, they still work. Yeah, so there's no connectivity there, not even resistance. Yeah, and I'm sure it's that top left pin there. Actually, I'll check in a minute. But yeah, so all we need is the diode from there to there. But what I will do now is just power it on and measure on volts DC here, just to make sure that on this positive tab here there are nothing, there's 0 volts, nothing. In fact, it should be floating. It's not a case of 0 volts, it should be floating. Yeah, so the side without the band goes to the positive side of the battery, and then the bands are going to come across and go to 18 here, the uppermost pin on that. So I've got a piece of heat shrink here because there's a pin right next to it here, there. So even though I'm going to bend the wire around here like that in order to, you know, solder it here, you know, there's a chance, isn't there, it could short here, so we'll get a piece of heat shrink over there. There we go, that's not so bad. And then we'll just heat that with some hot air now. Yeah, so low forward switching, 0.125 volts that diode, which means that it only eats 0.125 of a volt. You know, if you were to put a normal diode in there, like with a 0.7 volt drop, you measure your battery at 3 volts, and what's actually getting to the real-time clock will be 0.7 volts less. That'll do. Measuring from ground to the positive tab there. Yeah, something around here, when just with a slight bit of pressure, was affecting the video. Yeah, so there's no voltage there, switch that off. Let's get a button cell. Yeah, I don't like things like that. This is why I'm going to be testing it for a week, I think, here. Yeah, so that battery is 3.2 volts there. Hang on. That's it. Right, so the battery is in, and you knew I was going to do this, didn't you? You knew I was going to polish the top of the battery. It seems a bit ridiculous, really, doesn't it, when you look at the state of the board? But you know what? It doesn't look bad. It's like coordinated bodge. That's what it is. This is, you know, it looks tidy. It's tidy bodge. So let's now measure the real-time clock. So if I measure the upmost pin on the real-time clock chip here, there you go, 2.98 volts. Now the key is, just watch this, watch the voltage, because if you see that shooting down like, you know, quite a lot, like 2.6, 2.4, 2.3, 2.1, you know you're powering more than that IC on its own. But so there's diodes in place here that are obviously, you know, we replaced actually, probably the 1N4, 148s, and in fact they will be, because there's no other diodes around there, which mean everything is isolated. You know, the rest of the logic on this board can't feed from the battery connection, and likewise we've proven the charge circuit can't feed the battery. So that should be it now. I'm going to boot Amiga test kit again, real-time clock. Yeah, so that's progressing. We'll do reset, set time and day. Oh yeah, you can do it with the mouse, that's good. 7, save and exit. Leave it for a good, I don't know, 30 seconds or so. Real-time clock. There we go, Saturday, March 11th, 2023, 12:07:48. Fantastic. And I've shown what I do here so many times, the tap test. Not too hard that you dislodge things and move pins on socketed chips, but just a little bit of vibration stuff as part of the burn-in test here, because you know what? If you've got one bad trace or something somewhere, something that's just barely making a connection, this will root it out. But likewise, what I said before, don't hit and press too hard, because you've got wires under there that could get pressed into pins. and then you'll get a problem and you'll be wondering what the actual cause is. Just lift the board, drop it a little bit, just press around a little bit, flex slightly, you know. These are all the sorts of things when you get corrosion damage like this you'd be stupid to not do, because it'll just come back and haunt you. You'll have some minor connectivity thing somewhere that, you know, unless you do this sort of thing, you won't find it. Someone asked me a while back about these diode mods, you know, to use a CR2032, and they were trying to understand, well, if you've got now 3 volts roughly, just under around 3 volts going to the VDD pin on this, when you switch it on, what happens? Yeah, well, a diode will only switch when it can reach its forward switching voltage. So this one's 0.125 volts. The supply to this, when the Amiga's powered, I'll measure it in a second, but it's probably like 5 volts. The 5 volts probably just comes through as a diode drop, so it's going to be like 4.3-ish, maybe 4.4 volts-ish to the VDD pin. So because the voltage to the VDD pin is higher than the output of the cathode from the diode here, yeah, it can't switch. Yeah, and it's not reverse. You know, you don't get reverse bias, or, you know, you can't get reverse switching unless you were to fit a Zener. So the battery is isolated. Yeah, when it's powered, the battery's just disconnected, effectively. So yeah, that's how that works. We'll just measure the VDD pin on our real-time clock chip. There you go, 5.11. And this is the thing. So if I measure the battery, you'll see it'll be back to its full capacity. Look at that, 3.215. Yeah, because there's no switching. If I switch it off and we'll measure the battery, you'll see a little bit of a drop. 3.214. So now there's a slight drop, and if I measure the VDD pin on the real-time clock, there you go, 2.989. So yeah, all is good. And the final point here, we also had this in the 4000 for catheters. If this capacitor here is full of contamination, not working, what happens is this goes into, you know, it's not oscillating properly, and it just drains the power at a super high rate, from my experience. So you do need to make sure you've cleaned that out. That came off, it was soaked in vinegar, and it was scrubbed with IPA and deoxit in, rotated a few times, flushed out with IPA, contact cleaner in it, sprayed it out, some more deoxit in it, and then I installed it, and it works perfectly. But if you ever had a problem with this, I would suggest getting some contact cleaner in there and then just tweak left, right, left, right. You don't really need to adjust that very much, really. You don't really need to worry too much about where it's set. The one over here, you do. That is, you know, has a very, very strong relationship to the PLL, you know, the locking of the frequencies for the scan doubler stuff. But that one, it was a lot cleaner anyway. It's this one that's took the brunt of the corrosion from around here. Yeah, this is the pin next to VDD, so it's 32.769. I need to just remind myself, I'm having one of those senior moments at the moment. So I've got the trim tool in there, plastic one. Hang on, just going to tweak it a little bit. See it going down a little bit? Is it going up a bit? I'm not sure which way I'm going here. And obviously I need to... Oh, you can see the amplitude actually. It's affecting the amplitude a bit. Yeah, so we're not adjusting the frequency here. What we're doing is adjusting the amplitude. And you can see, you know, it's wider. It's going like narrower and wider. So it's a fine adjust for the frequency, I guess. 32.768. Yeah, I'm going to call it at that. 32.7687. So with the audio side of things, obviously make sure it sounds right. You can hear that. Switch the filter off and on. Yeah, filter has an effect. And obviously test the different modes there, you know, just get a sine wave going through and stuff. But if we just measure the voltages on here now. So the centre of the top of that op amp, so you've got minus 11.4. Obviously check on your power supply as well, but I've done that. That is correct. That's exactly the same at voltage. It's the minus 12. On the positive side, centre pin of the bottom side of the chip there, 12 volts. And again, check on your power supply, make sure you've got voltage drop, but that's correct, 1209. And then check the corner pins to the away from pin 1 here. Now while you've got audio, this is where you should scope it really, you can see we've got the bias there. Listen for the audio to stop now, there we go. And when it stops, you can see we've got a bias of 2.381, and the pin below it, again, corner bottom right, 2.381. So we scoped there, pin 8 first of all, that's the output, if you look at this diagram here, of one of the op amps, and then 7 of another op amp. there. So those just relate to one channel. And what we're measuring there obviously is the bias passing through that op amp. So you really should measure pin 10 to make sure you got your VREF that's roughly 2.5 volts there. And as we showed in a previous part, that is derived from a potential divider of 2 resistors. But obviously check the other channel above, so you know the VREF on pin 12, but then you want to measure pin 14 and pin 1, and you should, you know, in this silence, see approximately the bias level there, you know, from the VREF. Yeah, so we're getting to the final few pedantic things now. A bit of deoxit on a cotton bud, and we'll have a clean around these. Yeah, they're pretty good actually. Sometimes if corrosion's got on there, obviously you'd need to do a lot more work to them, and if they're, you know, just oxidized, you may do as well. You've seen me use the fiberglass pen to clean these on the 2000, and those were really oxidized. They had like a big thick ring of oxidization around the back, but these aren't too bad. And then get a wee bit of deoxit onto the end of that, and I'll jab it in there, and then do a bit of that into each one. And just for good measure, even though it doesn't need it, we'll just have a spray into that. But that switch is working fine. I forget which way up it needs to be now. I need to test the scan doubler again now anyway. Yeah, clean that as well. That'll do. Yeah, so I prefer to try and mask things like that off, just so that you don't get contact cleaner everywhere. Yeah, there we go, 32.768. So I've adjusted it with pin 16, yeah, instead of 17. So that's probably more accurate. So I mean, I'll test that over a period of time now, see if it loses any minutes. I need to adjust the time because it's a few minutes out. And then we'll plug the VGA cable in. Yay, still in calibration, you know, in regards to the PLL there, and it is. So let's boot ATK. Doesn't like look great. So this is the key. The video modes, gradients, they always look nice. These two though, if you've not got it dialed in right, that's the static cross checkerboard. Yeah, if you've not got these dialed in right, it'll look terrible, but that looks perfect, absolutely crystal clear, amazing. So yeah, as good as the day it rolled off the factory production line. Real-time clock, and checking on the wall, 1450. It's 1450, so that little tweak into the crystal, you know, the trim cap there, it was needed because it was running slow actually. So just waiting now for it to wrap over on the TV. I'll tell you when it changes to 51, 1451. It's 1450, 1450, 51. Yeah, so the TV changed at pretty much the same time. There might be a second or something in it, but yeah, that's a lot better. So yeah, if you do adjust the real-time clock, use pin 16, not 17 when you're scoping. So I'm glad this hasn't gone back yet. It fixed 3 connections on Paula over the last week or 2, as we occasionally got like a white screen flashing, you know, like flash white and then reset. Yeah, logic program Paula, oh, missing connection, solder wire. It worked for a few days. Then the same thing would happen, different connection on Paula, different connection on Paula. We're now on the 4th one of these, but I've dealt with all the wires. It's the ones that come down here in this area that's been covered, and it was like heavily corroded on the underside, worse than the top side, I would say. So yeah, pretty much, well, every one of those wires now has been patched. I think this is the last one. So one by one, they've all just stopped making a connection, and I've just measured on connectivity, and there is no connectivity. So that is the problem. It's not just the fact that the logic probe's mistaken. Yeah, and there was, you know, it's high impedance. There was nothing on the logic probe. It's just the 4th from the right hand side. 1, 2, 3, 4. Yeah, so if we start the one next to it, that goes there. The one we're dealing with is not. Oh, it's connected again now. Yeah, so this is the amazing thing. Just from heating that, it's now connected again. But I'm going to solder the wire anyway, because otherwise the problem will never go away. Right, test kit updated to 1.2. That was a trauma. You know, you get great ideas. You know what they say about great ideas. I thought, I'll go and write test kit, you know, the new version on the 1200. Well, of course, the 1200 wouldn't boot, would it? And we're getting some errors there, look. Yeah, the 1200's got the TF1260 in there. and ever since I fitted that, I've got some power related issues. The power socket is really loose. I mean, like so loose, the power connector could almost fall out. So I need to replace the power socket, I think, on my 1200. That's going to be fun. They'll sell for about £60 each now on some of those power connectors. I'm not going to worry too much about that, because actually Amiga test kit is really small and it loaded fine. So that's something further on into the disk. And I think it's actually the disk. So again, I'll just leave that going for an hour or two, get this thing nice and warm, because that's where you get expansion of traces and things, and that's where this problem started actually. This demo had been running for about 10 minutes and it warmed up, and then we got a bad connection on Paula. So just finishing up cleaning and stuff here. Yeah, I printed off a label, and yeah, there's some time travel something involved here. I swear it said March 2023. And it now says March 2025, so I had to print another one off, March 2023. I think what I'm going to do, you know me, I don't like to waste anything, I'm going to put that in the drawer, and we're going to recap something, and if I'm still here and the world hasn't ended, I'm going to recap something in March 2025 and use that label. So here we are about, I don't know, 4 or 5 days later, just seeing what the real-time clock is like, and obviously stability is good, this machine boots every single time now. So it says 13:05, there you go, that's 13:05 on the TV. Yeah, so there's a few seconds difference there, but it's holding the time date no problem, so I'm pretty comfortable. The time date side on that is solid. So near the end now, I am excited to get this back to Chris. Yeah, I'm going to stick the label here. I spoke to a few people, Screamo, you know, Stefan, and Liv2, and they suggested somewhere around this side, actually. Because obviously I haven't got the case for this, but I don't own a case, so I was like, well, where shall I stick that label to indicate it's being recapped so that it's visible most easily once the lid's off? And someone suggested on one of these chips here. Well, you can barely read the print on Paula there. The pins are nice and clean on it, but yeah, the print was worn away by the corrosion, so it's obvious it's Paula. So let's stick the label there like that. Recapped March 2023. Red dots on that, so it's absolutely crystal clear. I'll stick one on that tantalum over there as well. Yeah, it's crystal clear that you know, everything that's marked is recapped, you know, has been replaced. Because obviously I haven't done the daughter board. You can also notice I stuck a heatsink on here. I had one spare, and I got some new thermal tape to test out. Really strong, sturdy stuff, and that is well and truly stuck on there. So I figure, you know, it's a rare Agnes. You could, if this was mine, get a heatsink on Ramsey, maybe one on the Super Buster. I think that's the same as on the 4000, so there's still quite a few of those available, I think. Post in the comments down below if you know otherwise, but I'm guessing it uses the same Super Buster. You know, it's just kind of like 32-bit support with the Zorro 3 side of things. I don't think there's anything different between the 3000 Super Buster and the 4000 Super Buster, but I could be wrong. The Super DMAC, I would definitely get heatsink on that, even though these things may not get hot. And then obviously you've got the Fat Gary. Again, I think that's bespoke to the 3000. Maybe even you could heatsink the CPU, but yeah, I mean, you can get those as spares pretty easily. But customs that are rare, I would always heatsink them even if they don't get hot. Maybe even get a small one on amber. I don't know whether amber gets hot or not. That reminds me, and we'll do that now. Let's take amber out. I've got my own amber. Yeah, it came from Stefan, which was really cool. And let's try and remove amber again. Amber's been out here because obviously I cleaned the pins and the socket just carefully. There we go. Squeeze inwards and lift. Pins look good. Yeah, still very clean there. I actually used some deoxit as well. Here's the amber that came from Stefan. I think he may have got this from Canada, from someone in Canada, one of his friends. That was really, really good of him. Now I've got to try and work pin one as it's down here in the middle. So the notch is there, so let's just carefully align it with that side. It's in the right place, let's just press it down. I hope this works. Yeah, VGA is connected, but we have a problem. Now, does that need dialing in a little bit more? Is that the issue? Or have I got a faulty amber? I actually think I've got a faulty amber here. Oh, that is so annoying. And actually, you can see that amber is affecting the main display. Let's just switch it off. I'm just going to clean up the pins on it. I'll take it out again. Yeah, so the wrist strap is still on. Let's just have a wee clean around here. Because you know what? Maybe it is a bit oxidised, that. Hang on a minute, we've got a bent pin there. Yeah, that's the thing. before you test something, do check the blooming pins. I thought I'd checked it previously, so you know what, if this is damaged now as a result of this, this is my bad, which will be gutting because ambers are so blooming hard to find. Yeah, it is. It's shorting to the pin next to it. And it's not pushing it into the socket that's done that. It's got a bend on it. It's been previously bent, and the pin next to it slightly. Right, so those are now almost isolated from each other, just moving it a bit more. So let's carefully push that in. Please work. Woohoo! Yes! And it looks crystal clear on the VGA. Let's just boot test kit. See what that looks like. Yeah, that looks sweet. And of course, the proof is in the pudding. In other words, you've got to do these tests here. Colour bars looks good. This one here, though, is a key one. Yeah, that looks really crystal clear. Checkerboard on the alternating checkerboard, crystal clear. So thanks ever so much for that chip, Stefan. Hang on a minute, it's stuck now, I think. That's it. Just in case one of them has been bent, and just by process of lifting them out here, they can bend. So I'll inspect that under magnification now before I put it back into the ESD bag. But anyway, it looks pretty good, so I'll stick his amber back in. Pin 1 down here, wrist strap still on. Just sort of. You've got to juggle these around sometimes a little bit just to get it just in the right position. You know, you can have it misaligned a little bit on one side and then it goes in at an angle, and then before you know it, you've bent pins. So that's totally straight. Let's get it in. I'll just test it again now just to make sure that is working. Yes, there's 1, 2, 3, 4 axial caps on here and one 22 microfarad shui there. So yeah, my recommendation to Chris is maybe just swap that cap. I haven't got any more 22s left, but it's easy just to disconnect this and deal with this board on its own. Yes, there's a 7.4 series there, 7.4 series there. Right at the start of this, Chris led me to believe, and I think he'd been led to believe, that these wouldn't boot without this. Well, it does. It works fine without it, but it also works with it. The Zorro cards work and stuff. So you got two 16-bit ISA slots here. So if you had a PC card plugged in, you've got one ISA slot, which yeah, it's a bit limiting compared to the 2000, isn't it? Can't quite remember how many slots there are on the 4000, but you've got a similar kind of limitation there versus the 2000. And then the video slot is here. Again, a limitation in the terms of if you had a full-length Zorro card here, well, you can't use this slot for your video output. But then, do you really need that? Because you've got the scan doubler built in, so you can argue, is it really any use unless you put like a Cybervision card that maybe connects to both of these? That's a possibility. It might go into the Zorro half and then provide the video output here for the your RTG sort of side of things. So, but you've obviously only got 4 Zorro 2 slots, and again, the Zorro 2 slots, if the full length, could block these slots. So yeah, I quite like the 2000 in that respect. It's perhaps got a lot more space in there than the 3000 or the 4000. And of course, you could get products that would deal with that issue, like the High Flyer. I don't know whether there was one for the 3000. I think there was, because I don't think you could fit the video toaster in there properly, could you? So that's where the High Flyer came in, and it's like you take the lid off your machine and then something connects into here that raises up and gives you a load more slots inside the case, and you have like an extended lid that fits on top. Yeah, I'm never going to get one of those on my channel, I don't think. They're like rare as hen's teeth and very expensive probably. And the slots here look pretty much unused. There's not a sign of corrosion on them anywhere. So yeah, Ramsey, just like in the 4000, is the same chip actually. You can interchange the chips between the 3000 and 4000, but there's different revisions of this, and it does the address generation for the DMA transfers. So because I think this supports 32-bit, this is where it came in with the Zorro 3 stuff, you've got a 32-bit range where you can DMA to and from using the Super DMAC. The original DMAC, the one that's on the A590, that only provided a 24-bit address generation for DMA transfers. But the complication comes on these 3000s with the different revisions. The Super DMAC that this has got is an 02, so this is the much more common one. The 04 is a lot rarer. I'm not sure if it probably will have just started to ship with the later machines. It may have come in with the 3000Ts, and I think that's why it's so rare, and it's a lot more expensive. They're incredibly hard to find, near impossible. You might pay £500 upwards for a Super DMAC. Now, one of the guys on my Discord, I think it's Mike T, please correct me if I'm wrong. I hope I'm right. I've did a bit of research through my Discord messages because there's a lot of useful information in there. There's been conversations going on between a number of the guys talking about these chips, so it's it's educated me to be able to pass some of this information on. Yeah, so anyway, I think Mike T's been reverse engineering this and producing some Verilog or something to, you know, stick it in an FPGA or something, so that'll be super cool if he gets to completion with that project. But yeah, he's doing really well with it. And a lot of the information I'm about to share with you here has come from my Discord, from Liv2, from Mike T, from Andy Tricklebank. Yeah, so some really cool guys on there who've got 3000s themselves and done lots of tinkering and are obviously doing lots of research. Yeah, so the revision of your Super DMAC ties into whether things will work properly or not in all scenarios, depending on the version of RAMs you've got. And now there's a lot of misinformation out there, and what I'm about to tell you might not be absolutely crystal clear, conclusive facts, if you see what I mean. But what we do know, and this bit of information came from Liv2, I think, Ramsey 04, this one has a Ramsey 04, it increments in long words, yeah? Ramsey 07, which I think is the one on the 4000 actually, you can get those off any 4000 board, that increments in words instead. So when we say words, we're talking about 16-bit words, and long words, 32-bit words, I think that's what we're talking about here, long words. Certainly from a program perspective, yes, I have a red finger here, been caught red-handed. But there's a relationship between Ramsey and the Super DMAC in terms of those DMA transfers. So this is where you need a Ramsey 04 if you've got a Super DMAC 02, so these two, you know, work together correctly. If you were to fit a Super DMAC 04, then you need a Ramsey 07, from what I understand. Now, there are people out there who seem to have got combinations of these things the other way around, and they seem to work. And that ties in with maybe something I read from Mike T. And he was saying that as part of his reverse engineering of the Super DMAC there, he's been looking at the code obviously behind the scenes in Kickstart and Workbench. And one of the things that happens in Workbench when it's running, booting, it checks what version of Super DMAC you've got. So then when it comes to the Ramsey side of accessing that memory, instead of incrementing in long words, it could maybe just go back to incrementing in words because your Super DMAC isn't the right one. Do you see what I mean? And this might be the way it works for some people with combinations of these that perhaps shouldn't work. And SCSI, incidentally, is the main issue that people get. You know, they get problems with SCSI. SCSI just flaking out and stuff, and, you know, failing to do a transfer or freezing the machine or whatever. Incidentally, you can run a 3000 without a Super DMAC. You just lose the SCSI. Yeah, that is the main purpose of that. And before I forget, I think it's Mike T again has actually produced an adapter for this. And he kindly offered to send me one of these when I was having problems repairing this to fit an 8375 here. Now, this is where things get really confusing, because you know what? There is an 8375 that will plug straight into that. The Commodore and their insane part numbering scheme of things. Just, I don't know what they're playing at, but yeah, there is an this is an 8372, but it's an 8372AB. The B on the end means it's a 2 meg version, but it's bespoke to this. So if you were to fit an 8375 from a 500 plus, it won't go in here. Yeah, the pinout is different. So yeah, Mike T has produced an adapter to stick an A500 plus or a 2000 8375 into this profile here. You know, it's an adapter, just like the one Liv2 produced. So I might get one of those at some point, but obviously this board will have gone, so I'll need to test that some other way. And of course, the next complication here with regards to the Ramsey, certainly, the chip's here. And it's not really a complication as such, but the software you can get that makes use of, registers and things in Ramsey to control, to get better performance, yeah? To change the wait states. One of the guys in Discord mentioned this in terms of the 4000. You can run a Ramsey executable or something and, say I want to use EDO RAM, 69 seconds. Now, EDO RAM I didn't even think would work on these boards, and it doesn't in EDO mode, but it does in fast page mode. Well, not here, because we haven't got sims. What I'm trying to get at here is Ramsey can be used to adjust the timing of RAM and make use of features of that RAM. So all of this RAM is a static column memory, and I think it can be used with burst modes, but only compatible with the 030. From what I read, is if you've got an 040, the burst mode's not supported, even though it's supported in Kickstart 3, I think. And not all the SIP RAM's the same, I think, in terms of static column mode. I'm not sure if that's and this is where I get confused, I'm not sure if that's the standard thing that it needs to support, or whether that's what it needs to support in order to support burst mode on an A30. Again, some of the guys were talking about this recently. I can't find the threads though, but what I do know is these are not all the same. So what I would say to Chris when he gets this back, if he starts to play around with Ramsey and timing and trying to get better performance or burst mode or something going here, just bear in mind it might not work, because one or two of these are a different part number to all the others. I forget which one it is. If I'd known that in advance, I would have now marked them with a white dot or something. But you know, if you pull these out and look at the part number, two of them have got a completely different part number to the others, which make me think that he may have an issue here in terms of if he starts to fiddle around with Ramsey settings and try and tweak performance to get sort of switch one or, you know, another mode there that gives him burst or something. I don't know. Yeah, again, I'm talking about things that I'm not really up on in terms of, you know, I'm just going off what I've read here. And in terms of this RAM, again, a comment from Mike T. The reverse engineering he's been doing on the Super DMAC, he's proven that there's a relationship, or, you know, that you need to think about bus cycle termination, I think, in terms of this RAM. So the RAM can be a problem in terms of DMA transfers. So if you've got a combination of Ramsey and Super DMAC out there, and you're finding you're getting problems, it might not necessarily be the revisions of those chips you've got. It could be the RAM. It could be to do with cycle termination. You might find if you swapped that RAM for some other brand of RAM with a, I don't know, a part number that supports burst mode and static column mode the way it's supposed to be supported timing wise, you might find it works. This is the thing. So your RAM can have a relationship to the issue with Ramsey and Super DMAC when you're doing DMA transfers. So yeah, don't just assume it's one of the two chips there. But obviously, I would assume you're going to get best performance with a Super DMAC 04 and a Ramsey 07. With RAM that's all matching here, not some oddball situation where you've got one or two chips that may be different. You might get some issue with that. Now, I'm guessing the spaces here, and I haven't researched this, but I'm just guessing, there's sufficient space here for 1 megabytes. And I'm guessing the space down here originally had the RAM that was over in the chip position. It looks like they're the same size sockets. So if you get one of these boards and this is populated but your chip RAM space isn't, you can just remove the RAM from here and stick it in your chip RAM position, I think, and gain 2 meg of chip. But I would assume that this was 1 meg of fast RAM that these came fitted with, maybe, and nothing here. But you might have been able to optionally, you know, have a certain amount of this RAM fitted from factory. And I'm also making the assumption here that you can't just fit a meg of RAM there and have the RAM here giving you, you know, a theoretical 17 meg. I think you've got to have either 1 meg or then start to use these. I could be wrong. Again, post in the comments down below if you know otherwise. And the CPU, I mentioned this once or twice in this video. I think some of these are I think a 16 megahertz 030, and this is why there's a few jumpers here to say 1625, 1625, etc. So yeah, this one's got a 25, and obviously the jumpers are set to 25. You can still find these on AliExpress. You know, I bought one of those with an MMU in to fit on my 4000. There'll be a video top right to that. I'm not sure if this has an MMU or not. And looking at the part number, it's the FE one, so you know what, that might actually have an MMU. And I guess one final thing is, obviously you can get remakes of these boards, so if you've got a board that's this corroded and you're not prepared to spend the time that I put in, you could just get, you know, I think it's an Amiga 3000 plus, isn't it? Or a Amiga 3000. There's a few different products there, actually. The 3000 plus supports a few different extra things. I think it's got different types of RAM, so you don't have to mess around with these zip blooming packages. But I think it supports the DSP, doesn't it? You can get a DSP chip, and that was something I think Commodore planned in, because the revision of your Super DMAC has a bearing on that as well. Andy T pointed out that I think you need a Rev 4 because there's a difference on the DSP register. It may still work with a Rev 02 like this, but nevertheless, yeah, there's a relationship there. And the DSP is not a memory map device, it just sits completely disabled until it's turned on via the register in the Super DMAC. And then that DSP can literally be a bus master of the complete memory range there, so all the RAM in the system it can access, but obviously it's a bus master, it hogs the bus. So things like a SCSI transfer, DMA, you couldn't do a DMA transfer in parallel with the DSP doing something with the main RAM, but I think the DSP used on the 3000 plus has got internal RAM. I don't know how much, I'm kind of guessing 96k, it might be less than that. I'm just thinking it's a similar DSP from what I've seen in terms of the specs to what we used on the Atari Falcon. But what some people do is get a 3000 plus built. I'm not sure who builds those, it might be Chucky. But Chucky does the Amiga 3000s as well, actually. Yeah, and you can send an old board like this and it'll remove all the customs and things and connectors and things that he needs and fit them onto a new board, and you'll have a DSP socket and other, you know, new improvements over the original 3000 board. But going down the route of either getting a Amiga 3000 or, you know, a 3000 plus could just get you out of this pickle of having major trauma around here. We've managed it on this occasion, but you know what, if I got one of these again, I'm not sure. If I got one of these for myself now, I'd probably have a go at fixing it, but ultimately I think I'd then aim to get a Amiga 3000 board, and I probably would spend all the crazy hours to remove everything from the board and transplant it onto a new board. But even though this has taken a well over, I would say, 100 hours easily, I think it'd probably take me 100 hours to build a 3000 plus or a Amiga 3000. It would take an incredible amount of time for me to get all the stuff off this board, I'm sure. And it's ordering all the parts, yeah? All of the passives and things. If I didn't remove every one of these and just got new ones to put onto another board, it would take me forever to source all the parts. So one thing I haven't done here is to clean up the ROM legs. And the reason I'm doing this is because after a spot clean of the board, I noticed I was faffing around trying to get hair out from between the ROMs. And I did that, and then I came to power it back on, and I was getting a black screen. And I reseated everything, black screen. I was like, what on earth's happened now? I thought, was it that ROM? I was putting a bit of pressure onto one of the pins there, just trying to get that hair. And that's what it was. And it's just a bit of oxidisation. Could you see? They look a bit dull. You tend to find the main active ingredient in that stuff is IPA anyway. So it's not like it leaves a residue, it doesn't. It wouldn't be a really good contact cleaner if it did, would it? These I drew a line on. When they were in the socket like this, I drew a line on the bottom side here and a red line on the bottom side here. You can wipe it off with IPA, but it just means when you're taking them out, you're like, which way do they go around? Well, you know the outer edges, yeah? You could, you know, obviously stick an arrow or something. There's all sorts of things you can do, because it says ROM 0, ROM 1, and then you've just got part numbers on these that are a little bit cryptic unless you're used to them. These sockets here, exactly the same size as the chips. They're not, you know, like one pin larger like you get on some of the other Amigas. The other point with these is this is obviously a really old ROM set, yeah? The very first one, in fact, with the 1.4 beta on there. And that would have not shipped with this board. This is a Rev 9. So this is a later revision board, but it's got the earliest version ROMs. And those earliest version ROMs would have had a little carrier board, yeah, that they sit on the underside of. And I can only guess from that, because I haven't seen schematics or anything or read anything about it, but my guess is that original ROM carrier board, the reason you need to plug it into the sockets and have the chips on the underside here into some sockets on a little board is because Commodore balked, you know, the design and got the chip flipped or something. They thought it was going to be on the underside and it wasn't, the footprint was the wrong way around, or they flipped it or something. It could have also been to stop people sticking standard ROMs in. I wonder if their original intention was to have a bespoke ROM pin out, and then for whatever reason it was going to be too expensive, so they just, like I say, created a little PCB that plugs into the ROM sockets and has these chips mounted upside down on the underneath of the overhanging PCB. Yeah, I saw that on Chris Edwards' restoration. There'll be a link down below. He does quite a few different 3000s, and he had one of the older ones recently, and I saw it on there. But anyway, the ROMs, obviously, they are standard. You can just plug them straight into a later board, and they work. But my advice to Cathers is get 3.1.2 maybe for this, or, you know, or a 3.1, and then he'll be able to get an 040 card or an 060 card or something like that. And a reminder on that point, actually, if you start having problems with SCSI and you know, a card over there, just bear in mind all of this RAM is not the same. There's one or two, I think, chips here, maybe one, that's different from all the others. But in terms of all the memory tests I've done, everything checks out. But in terms of, you know, DMA, and as we were saying before about the version of DMAC and Ramsey, if you was to upgrade those, you might, and he starts tweaking the Ramsey settings, you might start running into problems with the fact that one of these is different. Yeah, there we go, Instaboots. So yeah, very pleased. I was a little bit alarmed though when it didn't work after just been cleaning up particles of dust with a piece of sellotape, effectively. I didn't understand what had gone on. But I did spend, you know, a few minutes messing around with that ROM socket trying to get a hair that would seem to be trapped. That's what it was. So file testing with a Zorro card here. I just went back to probing the data bus here on the RAM. It's doing the same thing as it was before. You know, it kind of looks like there's some contention. I mean, I do see logic high and logic low levels correct, but we've got those like mid peaks that are around 1.8 volts. So, you know, that's registering as a low, and it looks like that's the case because, you know, as I say, it goes high, and then you see it go right down to ground to get an actual low. So it's working, but is there still some sort of contention issue? Well, nothing really gets warm or anything, and I've tested all connectivity around everything around here, like numerous times as part of the trying to, you know, fix the last few issues. I think what I might do is I might just get one of the Amiga 500s out. I mean, I'm not going to see the same thing. You see, what's different here are these 646s, and I'm thinking that those are something to do with this. But you see, it could be timing on a signal somewhere, you know, an output enable, that means there is a bit of bus contention somewhere because something's not quite right. But we're not going to see that same sort of thing on a 500 because you haven't got the 646s. But you've got a DRD bus, and you've got chip RAM, and you've got Denise, and you've got Agnes, and whatever else connects to that bus. Yeah, I think from what I've just seen, I'm feeling so much better. I just probe one of the data bus pins, and I'll show you this on the scope. So Stephen might be right here. It might be about decoupling. That they deliberately haven't decoupled very much. But look at this. This is on a 500 plus. Sorry, not 500 plus, an R6 500. Press run stop. Look, down here, it's just the same, exactly the same. I think what's actually happening is it's fast and it's not pulling down low enough. Yeah, you've probably got pull-ups, so it's kind of like marginally pulled up by a certain level here. The pull-ups are the issue, perhaps internally, in order to get fast transitions to the highs, maybe. Post your comments down below, but you can see different logic levels here. Yeah, that's exactly how it looks on that 3000. Maybe slightly different because it's not quite as high up here and it's much higher there. You know, there's more of a contrast, but it's the same kind of thing. And as I say, that is data bus. You know, it's DRD on the chip RAM. So yeah, I'm comfortable. There's not a contention issue that I've missed or something. So it went on and on and on. This repair never ended, seriously. More bad connections. All on Paula is Paula. Paula is evil. On a 3000, Paula is seriously evil. From John Hurtle's PCB layout here, I'm just going to highlight, you can see here these buses of connections. Certainly on the underside, if those are corroded, fix every single one with a wire. Yes, you'll have a lot of wires, but you won't regret it. And then, if that wasn't bad enough, then the Amiga kit adapter broke again, as you can see here. Yeah, and then I finished off by replacing the audio coupling caps with some bipolars. It's the only two capacitors on the main board that I hadn't done. Just testing with a sine wave here, so I'll just mute that on the TV, because obviously it gets really annoying. Yeah, the reason I fit those bipolars, and I covered this before, and it's kind of a bit of a moot point because there's a tolerance on these capacitors, any capacitors really, for negative voltage swinging the other way just a little bit. If I just tap on and off that, hopefully you can see straight away that the negative peak goes beyond the ground line. Let me just tap it constantly. I'm tapping. Can you see that? If you look at the peaks at the bottom, they're below ground. So you do get a little negative swing there. And you may think, as others have said to me, it's not really a big deal. You know, it's a moot point because let's say the caps can tolerate that. But I've seen on numerous Amigas, the audio coupling caps there, leaking. I've seen it on both my 2000s, that issue exists. The other caps on the board haven't leaked. So, you know, you do the math. It's like, why do the audio coupling caps leak more than anything else? Because that is something I have seen. And it's not just on 1 or 2 boards, it's on 3 or 4 boards. The audio caps seem to start to leak and everything else doesn't. Alright, so the final bit of UV solder mask paint. So my advice to Cathers is, this is rock solid now, yeah, and I'm confident it'll be okay, provided you don't start going pressing things really hard and wrenching the board, which you could damage any board that suffered corrosion doing that, you know, pressing things really, really hard. But if you ever got a problem at some point, my guess would be it's going to be the buses on the underside. And when I say buses, I'm talking about, you know, a wide number, 6, 7, 8, etc. A bit like these here, yeah, a bus of tracers. The ones coming down from Denise and the CAA that come down to Paula. I would suggest this is the Achilles heel with this repair. It will be robust. If you stuck this in a case now and just used it, it'd be fine. I'm sure it'd last for pretty much forever until one of the main customs dies or something. So Chris, Cathers, if you do have an issue with this at any point in the future, by all means you can send it back, but obviously it's a lot to post and insure and all the rest of it. But what I would recommend is just look at the schematics for Paula and test connectivity. What you ideally need is a failure where it just doesn't work. It doesn't matter what you do, you reset the chips and it doesn't work, you're getting a fault. And then just test connectivity. You could use Logic Pro, but test connectivity on Paula. Yeah, just test every pin according to the schematic from the top side. So a final look at the battle scars here. Yeah, the solder mask paint. I learned a few things using this. The top side, it looks a lot cleaner than it does on the bottom side. I'm not sure why. I think it's because I've used it in small controlled areas where you've got, you know, large bits like this. You tend to find, you know, you handle the board, you touch it, it's not quite dry, and then it smears and it goes a bit horrible. But it doesn't dry very well. You know, it's taken an incredible amount of time to dry these two bits here. Yeah, it's dry now. You've got to use quite a lot of heat, you know, 150 degrees, maybe even up to 200. Well, you can't use 200 when you're near wires. This is the problem. But you can when there's no wires there. So perhaps, you know, if I was going to do something like this again, I would, you know, do what I did, gut this whole area, don't start to reinstall anything at all, fix every single trace, get your solder mask on, test all your traces, only when you're absolutely sure all your traces are good, all your pads are good, you know you're not going to need any fixed wires maybe, then start to install your components. But, you know, it's unrealistic to think you can fix every single trace on the top side and end up with no wires on the bottom side. Yeah, so a bit like that 3000, you know, the Archimedes 3000. I'm not really happy with the spaghetti stuff here, but you know what? When you get that much corrosion, you can't avoid it. You cannot avoid it. So yeah, there's a few bits of tactical hot melt glue there. But I think, you know, it doesn't look bad actually. If I zoom you in, yeah, there's lots of silvery solder there. Yeah, and down here we've got lots of copper. But every trace around there is good. It's going to be robust. It's going to be long term, I think. I feel quite confident with this, despite how difficult this repair has been. But you know what? Even that Archimedes, it had an issue. It's like fixed it, sold it, went to Xavier, and I think when he received it, said the IDE didn't work. Well, it worked when I sent it, so there was probably one bad connection somewhere. And this is the thing. You know, when you get this level of corrosion, this is why most people would not go near this with a barge pole. Yeah, and that was my first instinct right at the beginning. I was like, no, I'm going to refuse to do this. I think I'm going to send this back. Well, you know what? I'm glad I did it because it lives. And I think if he's careful with it, it could live for quite a long time. So obviously, I had two new RAMs. We had a faulty 245 here. Brand new, I think. Those, yeah, have at various points swapped them out. Initially, I couldn't get them working, as I explained. It's a case of the JEDECs that are available from Dave Haney's archive there for the PAL. These are actually PALs, and I was using a GAL. So you've got to use PAL to GAL. There's an exe you can download to convert the JED equations there from a, you know, what would be a PAL to a GAL. But nevertheless, the original GALs work fine. We've got a heatsink on Agnes. That does get hot. So it was a good idea to heatsink that. I think it's got its original Denise, pins on that were super clean. It's got its original Paula, pins on that were a bit green actually, but they've come up pretty clean. Just needs a little press on that side. Yeah, it wasn't straight in that, was it? These two have got short legs, these field RAM chips here, and you've got field RAM, smaller ones, that hold an entire frame. Sorry, did I say field? Yeah, frame RAM, field RAM. Holds an entire frame, and then you've got line buffer RAM, which you know, hold a single scan line at a time. So yeah, these ones, as I mentioned before, are larger in capacity than these ones, I think, but they're physically smaller. And the RTG side works perfectly. A guide I read suggested, don't put a socket there, these are really, really sensitive, these PLL chip sockets. That's not true. That guide was really good though, and very useful. I'll stick a link down below in terms of me getting the exact frequency when adjusting that. So it's had you know, the trim cap cleaned out, the trim cap there cleaned out. That had to be flushed out properly, taken off the board, as did that one actually. It's got a new tantalum there. We've got the low forward switching diode, like 0.125 volts or something for the real-time clock. It's got its original real-time clock chip. That was replaced. It's got its original PLL chip there, that's alright. That was replaced. As I mentioned a minute ago, sidestepping it, short legs on those. So those are the only two that got short legs. So just occasionally, after, I don't know, a few years of use, if you get any problems with the video on the scannable side, you may want to just check those are in there firmly. You could just order a couple of replacements of those with long legs, but they haven't slipped out, and all the time I've been working on this. But it's just something to point out, that when you remove the original chips from the board and think, I'll socket that, well, the legs are short on it. So yeah, in the case of these, it's not an issue. So yeah, Amber works perfectly, as does my Amber. So that was really handy having this to test that. Obviously a full set of Panasonic and Nichicons. These are Nichicons, that one's a Nichicon. Everything else on there is a Panasonic. So in general on these, you get loads of these 470s, you get loads of 47s, and then there's the odd 100, the odd 10, I think. Lots of 22s, several 22s. These are 22s, but now they're bipolars. And of course we swapped all of the ones back here and stuff as well. And I think it's nice to maybe to summarise, what do I think of the 3000 in general, having had the experience of working on this. And I would say it's nice, but this is an Achilles heel here. You're always going to, most of them, unless the battery's been removed, and you've not had much corrosion, you're always going to have a bit of a mare situation here. If you want to get the most performance and compatibility, you need the later Ramsey and the later Super DMAC. Well, good luck finding one of those. The Ramsey's not so much of a problem. You can get an 07 Ramsey pretty easily. Because this is the thing, I looked at one of these faulty on eBay a while back, a board, and I was like, oh, maybe I'll buy one of those and build one up. And I was like, well, this is unobtainium. The Super DMAC, it's unobtainium. You can replace the SCSI controller there easily. It's got some standard CAAs. Super Gary, wherever that is, that's there, isn't it? Yeah, Fat Gary. Hard to find that, because I think, isn't that related to this? You might be able to use a 4000 one, actually. This one's got a Rev 2, so yeah, post down below. Do you know about that? Could you put 4000 Super Gary on there, Fat Gary? Or was it Fat Gary and then Super Gary for the 4000? They could be different chips, but the Ramsey's the same. Maybe you could put a Gary on there without so much of a problem. Same with Super Buster. You can put the, this has got a Rev 7. You could put a Rev 11 Super Buster from a 4000 on there, I think. And then Denise is off the shelf, Paula's off the shelf. Amber, yeah, unobtainium. Really, I'm really lucky to have got the one I got from Stefan, actually. And the Agnes, yeah, the type of Agnes that goes in there, unobtainium, really. There's one on eBay at the moment, and I think it's like £300 or £400. And then in terms of RAM, yeah, this is the same kind of RAM you get on a 500 plus. So you've got 1 meg, 2 meg. So the zip RAM, pain in the bum, again, unobtainium. You can still get it, but it's blooming expensive. So a massive thanks to Cathers for entrusting me with this. I mean, I've done my best with it. I hope it lasts. This is the thing. He kindly provided a nice reel of chip quick solder here, 60/40 stuff. So that's brilliant. I'm always getting short on solder. You saw this earlier. This is amazing. He 3D printed this for me. So you've got large dip chips there, small dip chips there, and you can straighten the pins. That's fantastic. Got a silica gel thing here. I'm just going to lob that in at the bottom there and just try and get the air out of this as best as I can. I'll just carefully flip this over. Yeah, I'm going to be sort of sad and relieved to see this go. Yeah, I honestly can't thank Chris enough. There were times when I honestly wanted to smash that Amiga 3000 to pieces, I'll be completely honest. But he also included this. You've seen the chip quick solder included and the extractor tool. But it's a full kit here from Bike Delight, all of the components to build a Spectrum 128K. And the PCB, it's one of the purple ones you can see there. So yeah, that'll be an upcoming video. So yeah, I just can't thank him enough. It's like what started off as a traumatic experience for me and consumed so much time, ended up just being one of the best experiences of the year for me, really, until my birthday. There's more about that coming up soon. So yeah, thank you very much, Chris. And because of that amazing donation there, I was able to buy that case. So that will be something that I'm super excited to work on coming up soon. So I was pretty nervous when it went back to Chris, just based on the fact, you're like, well, what could fail? What could go wrong in transit, etc. So anyway, the first thing was, I nearly had a heart attack when he sent me a message saying, it's not black screen, it's not boon, black screen. I was like, maybe just check the jumpers. I didn't accidentally leave it in external, did I, when I was trying to test a CPU card or something? Yeah, in any case, it was the internal, external jumpers. But then the next problem he had was with the floppy drive. Now, as soon as he mentioned the problem he was having, straight away I was like, hang on a minute, I think I've saw this through my little journey here on the repair and didn't think anything at the time. There was a point earlier in this video where you'll notice that I put the Write Protect tab on after I wrote the Super Kickstart disk, and then it was working, and I didn't rethink about that. It didn't cross my mind. I just assumed there was some protection or something built in to, you know, you got to protect the disk or it won't boot, which would be a crazy thing really when you think about it in retrospect. Nevertheless, that was the problem he was having. He could only boot a disk if the Write Protect tab was on. And I think that may have been corrupting disks because it corrupted my test kit when I was doing some testing there. In retrospect, I realised that now. That was the reason why I upgraded my test kit. So I looked at the schematics and I theorised a little bit, talked to the guys on Discord, Liv2 suggested a few things, we got him to test a few things, and then ultimately I was theorising that it's going to be, you know, Occam's razor again, it's going to be a connection on Paula. So I was looking at Paula and its relationship to the floppy drive side of things, because Paula, you know, does have an involvement there, and I was theorising it was the DKW pin or something like that. You can see it here on the copy of the mail actually I sent to him, and yeah, I suggested that might be the issue, and he tested connectivity. He said yeah, there's no connectivity on that pin, from that pin on Paula to a specific 7.4 series. And my point was, well, you can either send it back to me and I can do it and I'll cover the shipping both ways. It was the least I could do because he did give me quite a large donation to cover my time, which was just not expected at all. But at the same time I said, you know, I've got every confidence you could do this fix if you really wanted to. You could just bodge a wire on the top. If you don't want to take the board out, you could just solder from the top of the pin on Paula with a wire to the top of the pin on the 7.4 series. You know, I'll tell you which one it is, etc. And here's the page of the schematic, etc. And he had a go. He took it out and he soldered the wire on himself and it fixed it. So brilliant work, Chris. You know, you saved me a load of stress, and obviously you've solved your own problem there. And this is what this channel's about. It's helping people, empowering people to be able to fix some of these things themselves. And I think he was thrilled to bits and I was thrilled to bits, and yeah, brilliant outcome. So then the next problem tied in with a RAM. So you'll notice a few minutes back in this video I was talking about the RAM, going, well, if you get problems with the RAM, it's going to be the RAM. Yeah, or if you get weird things and stuff with certain modes and DMA and all that sort of stuff. So Chris came to install a new version of Workbench. He was trying to upgrade to 3.2, I think, and as soon as it got to the set patch part, it would hang the system or reset or something. It was just, you know, it wouldn't boot. It would always fail around the set patch. And my point there was, I think it's that RAM. I think what you should do is remove like 8 or so of the modules, the ones that have got a different part number to the others, and just test them in two halves, you know, test the different types of chips on their own in isolation from the other type of chips, and see if any scenario there gives you, you know, a successful boot. And he couldn't get anywhere. I think he said there was more than one or two. I thought there were just a couple that were different. I honestly wasn't paying too much attention when I cleaned the RAM up in part 2 or part 3, I think it was. So anyway, he ordered a complete brand new set of RAM from somewhere, I don't know where, maybe China, of the exact correct part number with the right page mode stuff, static column support and all that sort of stuff. I'm not exactly clued up as to exactly what type of RAM you need on these, but nevertheless, when he fitted a complete set of 16 meg of the exact correct chips, it solved this problem. That's it. So there's nothing wrong with the RAM, but there was in terms of probably burst mode. I think when it was running set patch and CPU and stuff, it was probably doing something with burst mode. It's enabling burst mode or something like that. So anyway, a positive outcome again. Anyway, I do hope you found the video interesting. It's been a really long journey, this one. Spread over 5 parts. I'm sorry this episode went on so long. It would have been 6 parts had I split this one up. Yeah, and I thought the best way to close this video up is just show you a few photos, really. So you can see photos of his machine here and the fix he did to the floppy drive connection as well. But also the photos I took along the journey, I guess, as I was progressing through this board. So I do hope you found the video interesting. If you'd like to support the channel, please get coffee and Patreon links down below. I will catch you in the next video.